Hello everyone and welcome to this new video of computer science and artificial intelligence. So today we're going to code a linear regression. Exciting. So we're going to code that in Python completely, and I'm going to go step by step of how the code works, and pretty much that's what we're going to do. Exciting stuff. So in case you're coming here without actually watching Applied Derivatives 2, which is a series in which I explained how the linear regression works with the calculus and stuff, it is actually crucial that you go and watch that video. It's actually about 25 minutes, 20 to 25 minutes, and there I explain how a linear regression works. So the last time we were there, we actually were evaluating this problem that we have. So we are trying to estimate how much money we will make if we invest $10,000 on a company on the 15th month and hold stocks for 3 years. We can use pure mathematics, but as computer scientists, we'd rather let the computer do all the work for us. Great, so this is the data set that we have, and this is the graph. So as you can see, the growth in the price of the stock is kind of linear, so we can estimate the price using a linear regression, provided that the pattern does not change in the next 3 years. So we have data for the first month, second month, 4th month, 9th month, 10th month, 12th month, and 14th month. So to answer this question, we have to create or pretty much get a formula that will give us the answer to this question. Now, this is the line that we are trying to create with our linear regression. And just so you know, we're going to code a general linear regression that can give us the line for any function that grows linearly, or for any data set that grows linearly, right? So in this case, we're going to do it for, we're going to plug in these values here, and we should get this line here, and actually we'll be able to answer our question. So these are the formulas that we will use to get the answer to the question. So let's evaluate. So we have R, which is a return on investment. We have IV, which is the initial investment. We have T, which is the time of the investments in year. And then this is the kind of general formula. So it's better always to have like a general formula, because when you have a general formula, it's really easy to go from formula to actual code. So this is sort of a general formula, but specific to our question. So we can plug in any initial investment, and we can plug in any time that we want to invest for, and provided that we invest in the 15th month, it will give us the right answer. So actually I solved here, I factored out the IV, and I got this, pretty much this is the formula that we will use to get our answer. So also from our last video, we also got the equation of a line, we got the error function or the cost function, which is the sum of all the prediction of the model for xi minus yi squared. So we also got the partial derivative of the cost with respect to m, the slope, and we got the partial derivative of the cost with respect to b. So we also have our equation to update m to approximate m to the value that makes the cost 0. And this is the same thing for b, right? So we have our old b minus mu. Mu is like a small fraction times the actual cost, or the slope of the cost for b. And here the slope of the cost for m. Great. So we will use this kind of as our cheat sheet as we go on and program our code. So first we'll go ahead and program this, and then we'll move on to programming our linear regression. Great. So we'll go ahead and create this new project here. I'm using PyCharm, the community edition, which is, I think, a great IDE. So let's call this linear regression. That's essentially what we will do. So we will create 2 files for these, 2 Python files. So my first file will be called linear regression. This is where we will actually code our linear regression. And then let's create a new file. Let's call this one R return on investment. So I'm just gonna call it return INV. All right, so here we will import linear regression, and then as we move on from there, I'm just gonna import it as LR. So we're just going to go ahead and go into our main here. So if this is main, we want to do the following. But before we do that, let's go ahead and code our function based on the formula that we have here. So let's call this function return on investment. And it takes as a parameters two things. So initial investment, just gonna call initial investment, and the time in year. And then from there, it's actually a really simple formula. So we will have our R, or return on investment, be the initial investment, in this case is initial investment, times the prediction. I'm just going to, let's also pass as a parameter the linear regression model here. So let's just call it LR model. So this LR model is going to give us the equation of a line, and from there we can create predictions. So let's just say LR underscore model that predict. This will give us a prediction for a value, and we have 15 plus 12 times t. This is according to our formula, right? So this will be divided by LR model that predict in 15, and then we will subtract -1 to it. So according to the operation, so we will divide this over this, then we subtract 1, and then we'll multiply it by the initial investment, and this we can just return it, right? Great. So let me just clean this up a little. Great. So if name equals main, then let's just say return on investment for our initial investment, as per our problem, is 10,000. T is 3 years. And for the model, let's just have a placeholder there because we have not figured out how it's going to go, right? So let's just leave this for now there, and then we'll come back to it. Great. So here, I don't think I will be using any crazy modules, so let's just plug in our linear regression. So let's create our initializer. So remember that the first step of a linear regression, as per our previous video, is to randomly initialize M and B. So let's just have M and B be just any two values here, and let's just call M. So here's a module that I will be importing, import random, because we need some random values, right? So random, let's just say random. This will return a random number between -1 and 1, so actually between 0 and 1. So let's just multiply by 2 so that it's between 0 and 2, and let's subtract 1 so that it's between -1 and 1. Now let's do the same thing for B. So random times 2 minus 1. Great. So we have that there. I don't think we'll need to do anything more than that. This is just a simple linear regression. Great. Okay. So according to this, we need this function right here to update M needs the cost, the actual cost, or the total cost of the slope, or the slope of the cost with respect to M, and this one the slope of the cost with respect to B. Great. So we know that we will need these two functions, and luckily for us we have the one for one point, we can just add them together in a loop for all the points, right? So let's just create dcdm and pass. We'll define what we will do later, dcdm and dcdb. Let's pass that as well. Just for informational purposes, this is not really necessary, but I can also program the cost function, because what I want to do is make it so that while it's training, we can see some feedback on it, see the actual error, and see how it's decreasing. So there is another function that we need, of course, is a predict function. And I know right off the bat that it's going to take a next value, because we want to predict the mx plus minus y according to this x value. And this is actually pretty simple. Let me just say return self.m times x plus self.b. Not too hard, right? This is just the equation of a line. mx plus b. Great. So let's actually create the most important function here, which is the train function. You could call it the fit function also, but let's just call it the train function. So here we will have our data set. So our data set will consist of our x values and our y values. So we will accept those in an array, basically an array of arrays. So we'll have an array that contains each value pair, each x, y pair. Great. So the train function should be very easy to compute, because all we have to do is go in a loop. So let's see. Remember that we need a mu value. A mu value is like a very small value, because the training part is actually the updating the m and b, right? So what will we do? We need an m value, and we need a number of iterations that we want to do to train it. So I can hard code these values. So let me just say mu equals 0.001. I found that this is a good mu value. And then let's call the number of iterations and iterations. Let's say that 5,000, because 5,000 works fairly well for a linear regression. So great. So now let's see. We want to iterate as many iterations as we have here. So let's just say for I in range and iter. So we go with as many iterations as we have. Then we have to update m and b. What do we say? Self m minus equal, because remember that our formula says that is m, or a new m is old m minus a fraction of the slope of the cost. So let's say it's mu, or mu, times the cost. So self dc dm, because we're updating m. So here we will most likely have to add some parameters. Self b, same thing. Great. So what parameters do we probably have to pass here? We have to pass in the data set. We have to pass in the data set. That's pretty much it. And for the cost, we also have to pass in the data set. So let's just do it now. So let's just pass in the data set. Remember that the data set is the one constant in here. So our data set doesn't change. Great. So now let's actually code this, because this is all there is. The training part is just updating m and b. So for the actual cost, if we look at our function, it's just 2 times the x value times the prediction minus the y value there. Great. Make this simpler. Let's say total, because we want to compute the total slope of the cost, right? With respect to m. So let's just say total equals 0, and then let's iterate how many times? Well, let's just say for pair in dataset, because we want to compute the error for each pair xy pair of the dataset, right? So for pair in dataset, then we have that x equals pair in 0 and y equals pair in 1. Great. So remember that we will be passing this as an array of smaller arrays, and the smaller arrays contain the x and y pair in one single column or in one single array. So the first item will always be the x, the second item will always be the y. Great. So now that we have that done, let's just say that the total, we can increase it by 2 times x times we have the self predict for that particular x minus, this is in parentheses, minus y. This is just the same formula that we had before. It's a very simple thing. Alright, so let's do the exact same thing for here. So we have a total equals 0. So for pair in dataset, so we have x equals pair in 0. I'm just doing this for clarification purposes, guys. So I could have just left them as pair and used the pair on 0 here, pair of 1 here, but it's actually easier to see this way. So total plus equal, so in this case it's just 2 times the prediction of x minus y. Great, I could have just said self.m times x plus b, but we already have a function that does exactly that, so let's just take advantage of that. And then for the cost is pretty similar. So this is just for information purposes, and you will see y in dataset. So we have our x and our y. So remember that our error is just the prediction minus, for that x, minus y squared. So this is just Python for squared, in case you guys don't know. And then at the end of all this, we return the total, which I have not been doing here. Return total. Return total. And if you guys can guess it or not, we're done. This is pretty much it. All we have to do now is just add a little bit of information here to see what's happening. So let's just say print, right? So print before training m equals, so m equals self.m, b equals self.b. Okay, so this is just for information purposes. Let's just also print the error or the cost. So the cost equals self.cost for this data set. Great. So I want to go training this, but let me just create a little PC counter here so that I can, I just want to iterate here 10 times, print it 10 times for each of it. So if I over 10 equals BC, then, or let's just say, yeah, it's the same thing, right? So print basically this thing. So I'm just gonna say training m equals, I'm just gonna say So here I'm just going to print I. And then let me just print the cost right here. Great. So what do we do here? PC equals 0 again. And then here PC plus equal 1. Oops, this is not what I meant to put here. Okay, so every time you have a tenth of the total number of iterations, we're gonna print this information here. Great. So I think this is pretty much ready to start. I think this should start at 0. We're gonna test it anyways. But anyways, let's now move on to our actual code here. So return on investment. So now we can create our linear regression model. Remember that the name of the function is linear regression, right? So let's create a linear regression. Let me just call it linreg equals lr.linear regression. And we have to now add a data set. Great. But let me just build the data set here now. So the data set will consist of all the pairs in X and Y. So let me just do that real quick. Great, so this is our data set. Now let's just say linear regression dot train. And let's just pass in our data set, and now we can call this function, say return on investment, and we can pass in this object. Great. So now let's just output some things, right? So here, print. If we invest 10,000 on the 15th month, our earnings will be, then here we can print this earnings. And now let's hope that this actually works. If not, we can go back to it and fix it. Okay, so the cost here was very low, which suggests that we may have something here. However, the cost started very high, 397. However, I'm not really satisfied with this number, with this cost right here, so we can just adjust our parameters here. And you know what? I can just say that we'll pass in the mu here and the number of iterations so that we can adjust it from out there. So we're gonna say now where mu equals 0.001 and number of iterations is, let's say, 10,000. Great. So let's run this again, and the cost is much lower, much lower. And now we get a different number, which seems to be more accurate. Let's just make this print in a different way, because so 0.2f, this means that we just want 2 decimals, and let's just change this by this. Great. Now let's actually do 100,000 iterations, because I want this to be as low as possible. So this is what I'm looking at, the cost. Of course, I'm also looking at the bias, and I'm looking at the bias or the intercept, and I'm also looking at the M value. So let's see. So yeah, it looks like it did reach a lower value, and it seems like it's not going to reach any lower than that, because if you look at the previous ones, it's the same. Like after 10,000 iterations, it was still the same. So this is probably the best function or the best MMV value that fit this curve. Great. So that means that our code worked. Now, what do we have to do to test? Oh, yeah, of course. Let's actually find out how much money we will make. And it seems like we will make $10,000. Not bad at all. Not bad at all. We'll be making $10,000 or close to 11,000. So we'll end up in total with 28,000. Now, let's actually go back here and let the actual numbers to give us the function. And let's see, it says that y equals, this is our m value, because remember mx plus b, y equals 0.0256, and then b is 0.4652. Let's see what our things tells us. 0 to 56, great, and 0.4652, which is the same thing that this tells us. So that suggests that our function actually works very well. So this is pretty much all for this video. Thank you guys for watching. As always, I want to leave you with this thought here. Be curious, ask questions, try something out. So this is my code. You may have even a better way to code this. This is not the most efficient way to code it. I'm just trying to show it as clear as possible. Of course, this gives us an opportunity to actually go and improve this actual code, as we will do in the future. And as we move on to more complex things like coding an actual neural network, we'll be forced to actually make this code more efficient. Otherwise, it would take way too long. So, guys, once again, thank you for watching. My name is Brian Morphe. If you have any thoughts or any questions, please leave a comment. If you want me to share this code with you, I can also do that. Just leave a comment. Also like if you like this video, and subscribe if you want to see more. Thank you very much.